Hello everyone and welcome to our channel, Mootechie. It's wonderful to have you here as we dive into the fascinating world of chemistry. Today we're exploring the strengths of acids and bases, a topic that's fundamental to understanding so many chemical reactions around us. Let's begin with our essential question. How does the value of an acid dissociation constant relate to the strength of the acid, and how are those values calculated? Keep this question in mind as we move through the lesson. Now let's move on to our first key distinction. We have strong acids and weak acids. Strong acids are completely ionized in aqueous solution. A perfect example is hydrochloric acid. Its reaction looks like this. HCl plus H2O reacts to form H3O plus and CO minus. And importantly, this reaction is 100% ionized. In contrast, weak acids are only slightly ionized in aqueous solution. Take ethanoic acid, also known as acetic acid. Its reaction is CH3COOH plus H2O in equilibrium with H3O plus and CH3COO minus. This is only partially ionized. Next, we explore a table that shows the relative strengths of some common acids and bases. The table has 3 columns: substance, formula, and relative strength. For acids, hydrochloric acid, HCl, is a strong acid. Other strong acids include nitric acid, H9O3, and sulfuric acid, H2SO4. Then we have weaker acids like phosphoric acid, H3PO4, ethanoic acid, CH3COOH, carbonic acid, H2CO3, and hypochlorous acid, HClOO. On the base side, ammonia, NH3, is listed for a neutral solution. And then we have bases of increasing strength like sodium silicate, Na2SiO3, calcium hydroxide, CaOH2, sodium hydroxide, NaOH, and finally potassium hydroxide, KOH, which is a strong base. Coming up, we'll discuss acid dissociation visually. For a strong acid, the diagram shows complete dissociation. The acid HA fully breaks down into H3O plus and A minus in water. The chemical equation is HA aqueous plus H2O liquid yields H3O plus aqueous and A minus aqueous. Now for a weak acid, the diagram shows only moderate dissociation. You see some HA molecules remaining intact, while others have ionized into H3O plus and A minus. The reaction is shown as an equilibrium, HA aqueous plus H2O liquid in equilibrium with H3O plus aqueous and A minus aqueous. Following this, for a very weak acid, the diagram shows very little dissociation. Almost all of the HA molecules remain together with only a tiny fraction ionizing. The equation is shown with a single arrow indicating the reaction heavily favors the reactants. HA aqueous plus H2O liquid yields a very small amount of H3O plus aqueous and A minus aqueous. Let us now look at acid dissociation constants. These take the same form as the equilibrium constant expression from a balanced chemical equation. For ethanoic acid, for instance, the acid dissociation constant, Ka, is calculated as follows. Ka equals the concentration of H3O plus times the concentration of CH3COO minus divided by the concentration of CH3COOH times the concentration of H2O. These are sometimes called ionization constants. So what does this tell us about acid strength? Well, weak acids have small Ka values. Strong acids have large Ka values. In fact, the Ka value for HCl and water is considered infinite. Why do you think this is the case? It's because it dissociates completely. Moving forward, let's examine a table of dissociation constants for specific weak acids. For oxalic acid, its first ionization constant, Ka, is 5.6 times 10 to the negative 2. Phosphoric acid has 3 dissociation steps, with Ka values of 7.5 times 10 to the negative 3, 6.2 times 10 to the negative 8, and 4.8 times 10 to the negative 13, respectively. The table also lists values for methanoic acid, benzoic acid, ethanoic acid, and carbonic acid, which you can refer to for further study. Now, base dissociation constants work in a very similar way. Strong bases and weak bases refer to the degree of dissociation just like acids. For sodium hydroxide, for instance, the base dissociation constant would be calculated as the concentration of Na plus times the concentration of OH minus divided by the concentration of NaOH times the concentration of H2O. Next, we have a new essential question. What are the products of the reaction of an acid and a base when the endpoint of a titration is reached? This leads us directly into acid-base reactions. A mixture of a strong acid with an equal amount of a strong base results in a neutral solution. These reactions are called neutralization reactions. Let's understand this more clearly with some examples. Consider the reaction between hydrochloric acid and sodium hydroxide. HCl aqueous plus NaOH aqueous yields NaCl aqueous and H2O liquid. Another example is sulfuric acid with potassium hydroxide. H2SO4 aqueous plus 2KOH aqueous yields K2SO4 aqueous and H2O liquid. What would the net ionic equations for each of these reactions be? It's a great thing to think about. Now let's talk about titration. Acids and bases sometimes react in a 1-to-1 ratio, like HCl plus NaOH yields NaCl plus H2O. However, the ratio can vary. For instance, H2SO4 plus 2NaOH yields Na2SO4 plus 2H2O, or 2HCl plus CaOH2 yields CaCl2 plus 2H2O. This is important. When an acid and a base are mixed, the equivalence point is when the number of moles of hydrogen ions equals the number of moles of hydroxide ions. So, how is this used? You can determine the concentration of an acid in a solution by performing a neutralization reaction. For this, you must select an appropriate acid-base indicator. Phenolphthalein, for example, turns from colorless to pink as the pH changes from acidic to basic. And finally, here's how a typical titration is performed. A measured volume of an acid solution of unknown concentration is added to a flask, several drops of the indicator are added to the solution, then measured volumes of a base of known concentration are mixed into the acid until the indicator just barely changes color. And that brings us to the end of our session on the strengths of acids and bases. I hope this journey through dissociation constants and neutralization reactions has been enlightening for you. That's all for this lesson. Thank you. See you in the next class.